Okay, so the rules are, use the full name of the first element. Now, if you're not sure which element is the first one, the most metal-like, so the one that's closest, or that's on the most left-hand side. Put the name of the second element last and change the ending to, what do you think it might be? I, yes. Change the ending to I. So that's why, Carson, you knew what carbon monoxide. That follows the rules, but that's such a well, not common, but we know so much about carbon monoxide that we know how to name it, right? Use the correct prefix, and I'll tell you what those are in a minute, to indicate the number of each element. The exception is, do not use the prefix mono when the first element has one atom. So you guys knew that this was carbon monoxide. We don't have to call it monocarbon monoxide. You just call it carbon monoxide because the first element, even though it was one, we don't have to say mono in front of it. We can just say carbon monoxide. When hydrogen is the first element in the formula, the compound is molecular, but prefixes are not used. And that's because they're acids, and I'll tell you about that later. Okay, so prefixes. A lot of you will know these. So this is the last kind of box on your memory sheet, and we'll put it in our notes. So this is something you need to memorize, but I bet a lot of you will know them, and we've already talked about them with our hydrates. So, number of atoms, put in 1, 2, up to 10. So let's see how much you remember from when we did our hydrates. So 1, I've already talked about it. What is that? Mono. 2 is di. 3 is tri. 4, tetra. 5, penta, the pentagon. 6, hexa, hex. 7, hept, yeah. Hepta. 8, octa, that's an easy one, yeah, that's nice. What is 9? Nona, yeah. And 10, deca. Yeah. So make sure these are on your memory sheet as well. Again, keep your memory sheet kind of tucked in with your other things. Now, if you go to the back of your memory sheet, it says there's a couple things here. Ionic compound is what? An ionic bond is what? How to name an ionic compound and give an example. Molecular compound is what? Covalent bond is what? How to name a molecular compound and give an example. If you put this on this sheet, like if you fill this in with the notes you have, this sheet will be very good for you. Because then it will have it all summarized about how to do everything with compounds. And then you can keep this kind of with you. Okay? So I'm not going to take it in for homework, but this would be a really great sheet for you to fill in. Well, there might be the occasion that if you have it done, I might say pull out your memory sheet, you get to use it. It's happened on occasion that I reward those who have done extra work. So, I don't know, it might. You might see it creep. Okay. All right. If I feel like you guys are really stressed out, but you've been working really hard, that's when I would say you can take it out. Okay, so let's do an example. So here's just a little summary of how to do it. The prefix plus the first element, then the prefix plus the second element with I. The exception is don't add mono if the first element is just one. So this one, of course, what is it? Carbon is our first, and then our second is monoxide. So monoxide. We won't put 2 O's because that would be weird. Carbon monoxide. Okay, so let's try the next one. So we have the first element, the prefix with the first element, then the prefix with the second element. So, do I need a prefix for this? No, because there's just one. So I'm going to say it's nitrogen. And then I need a prefix for my O. How many O's do I have? 3, yeah. So I go nitrogen trioxide. Now you put this all into one word. I'm just writing 2 lines to kind of show you. Okay, so the next one, we have a prefix, the element, prefix, element. So, how many nitrogens? 2, so we put dinitrogen. How many oxygens? 1 monoxide. Prefix, element, prefix, element. Do I need a prefix for this one? No? So just nitrogen, trifluoride. Oh, good, I did. All right, the next thing is prefix, name, prefix, name. So I have 2 nitrogens, so di, then nitrogen, trioxide. You guys hot? You can crack the window open. Okay. You can open the window. You guys are hot. Yeah, the hinges are a little busted on them. Okay, so we are going to finish this lesson. I know it's a bit of a long lesson, but I'm not going to be here tomorrow. So after your quiz, you get the rest of the time to work on the questions, okay? So that's why I'm doing the full lesson today, almost like 2 lessons today. So then after your quiz, you have the full time to work. So you don't have to do it all for homework or anything.
Who's our teacher?
Mrs. Kramer.
Oh.
Yeah, so she can help you? Yeah. Okay, so now we've talked about kind of what are molecular compounds. We've talked about how to name molecular compounds. But now we're going to look at how are they actually formed. Okay? What do they look like? So the formation of molecular compounds can be explained using a Lewis diagram. Now remember, we've already done Lewis diagrams. What else did we call them? Electron dot diagrams, okay? So remember that Lewis structures represent the valence electrons, right? That's all you have to draw. Now, the number of valence electrons can be found using what? What's the easiest way to figure it out? The group number, yeah, the group number going down. Now, we kind of talked about this before, but when we think about electrons being, or valence electrons when they're all by themselves, like they're not in a pair, what are they called? Very something special. When they're all by them, so like this, if I was looking at chlorine, and here's one electron all by itself, do you remember what that was called?
Unstable.
It is unstable, yeah. Do you remember what these are called together? They are stable. These were called a lone pair.
Oh, and those were
Close, bonding electrons. Okay. So electrons that are by themselves in the Lewis structure are called bonding electrons. Now, in molecular compounds, the covalent bond involves sharing electrons rather than the ionic, which exchanges them. And we can represent that with the dot diagrams. So let's say, here I'll show you a couple examples. Say we have two nonmetals. Well, I'll just give you the example of when oxygen exists as an element. So its molecular formula is O2. But we just call it oxygen because that's just as it is as an element. So this is oxygen as an element.
What is it when it's just by itself? Like, what's it called?
What do you mean? Sorry, go ahead.
Like, on the table before, like, what's it called when it's just
Like
still considered an element?
over here?
Yeah.
Okay guys, I feel like I'm really talking over you. Do you need to share something? No? Okay. Maybe just limit the chatter, because I know you're being quiet, but I just can't. So, like, do you mean when we were going like O2 minus or something?
Yeah.
That would have been an oxygen ion.
Okay.
Yeah. Okay, so this, when we think about oxygen as an element, like as it is floating in the air, it has to be O2. So, this says electron dot diagram of each nonmetal. So we have to draw two oxygens. So there's 1, 2. They're in group 16. Do I draw 16 electrons? 6. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so now, look, I have this bonding electron, and this bonding electron, this one, and this one. So all those bonding electrons from those oxygens are going to be shared. So what I do, this is kind of a unique one, is we have our oxygen and our oxygen. Here's my lone pairs. I'm just going to put them on the other side so they're out of the way. And then these guys, say this one and this one are going to meet up. And then this one and this one will meet up. So this is kind of a special one because they are, this is called the double bond right now. So I can simplify this and go like this, O, and then I draw two lines to represent a double bond.
That's it.
Yeah. And I don't have to draw, like, for a test or whatever, I want you to show me this for sure. If you want to simplify it, you can show me that too. But make sure you've shown me this, okay? This is a simplified version, and we do this a lot in organic chemistry in Chem 30. It's fun. And I'll show you how to do that with some of these in a bit. We can play with them. Okay, so how about this one? Carbon tetrabromide. So what I'm dealing with is carbon and bromine. Those are my two things. So let's draw a carbon. 1, 2, 3, 4, because it's in group 14, so I use the number 4. And then I need, how many is tetra? 4. So I might actually write this out for myself. CBr4. That's what I need to get. So I'm going to draw 4 bromines in this spot. So Br, and it has 7, because it's in group 17. 1, 2, 3, 4, 5, 6, 7. Now, just because I've done this a couple times, and to save on space, I'm going to put a bromine around each kind of corner. So here's another bromine. Okay. Now, each bromine that has a bonding electron will go to one of the bonding electrons with the carbon. So like this one and this one, they're going to meet up. This one and this one, they'll meet up. This one's all the way over here, and this one.
Do you have to draw like exactly like that?
No, I'm just kind of representing to you what's going
So
on.
could you do like arrows?
Sure, you can use arrows, yeah. Even if you didn't draw arrows, that's fine. I just want you to show me the electron dot diagrams of each one. But the next part will be kind of, it'll make more sense. So now, what you do always with carbon is basically you build things around carbon, because carbon is essentially the building block of life. So when you're dealing with molecules with carbon, everything kind of builds around it. That's why when we talk about organic molecules, they're everything with carbon in them, because carbon forms so many things. Okay, so now we put a bromine beside each one. Fill it in. This I would like to look like the exact same. However you did that one is fine. So it's like the bonding electron from bromine and carbon are sharing them. See, they're sharing them in each one. They're being shared. You don't have to draw the circles I just drew, I'm just showing them to you. So that's how I end up with a molecular compound. So now each element is stable. Each element is stable now, because if we count, each element should have 8 valence electrons. So if we look at carbon, it has 1, 2, 3, 4, 5, 6, 7, 8 around it. Bromine, 1, 2, 3, 4, 5, 6, 7, 8. So each bromine has 8 around it, and the carbon has 8 around it. So that means it's all stable. So they all had to share it to make it work. Yeah. So now you can do workbooks page 8 to 10, I'm pretty sure. Oh wait, yeah. I want to show you the simplified version. Was that what you were going to bring up? But I'll answer your question next year. Okay, so how could I simplify this? You could draw the C, and then 1, 2, 3, 4, bromine, 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 bromine. So that's simplified. The line just represents shared electrons. One pair of shared electrons. You don't have to know that. That's what we'll do in Chem 30. Okay. Yes. So instead of that, you're showing it both times. So you're showing it like that. You got to either you have to erase it, or you have to erase it. Uh-huh. Oh, thanks.